Hello everyone, welcome to my channel. I am Manish Singh. Today we will study about the states of matter, 10th IGCSE chemistry, right? So our first topic is, so you can see our first topic is based on everything is made up of particles, right? So how everything is made up of particles. So look at the first point, made of particles, right? So like examples like rock, air, water look very different, right? They are they look very different from each other, rock, air, and water. But they have one big things in common. But they have one common things in them. They are all made of very tiny pieces, far too small to see. Right. For the moment, we will call these particles, these species called particles. Right. So tiny pieces is called as particles here. In fact, everything around you is made up of particles, right? So everything is made up of particles. So now look at the next point, particles on the move. In rock and other solid, particles are not free to move around, right? So in solid state, particles are not free to move. They are bonded to each other, right? So particles are bonded to each other in solid state, right? But in liquid and gases, they move freely. But when liquid comes, particles are far away from each other. This is your liquid state. So they are far away from each other, and in gases, they are very far away from each other. So they can move freely in any direction. So this is for your gases, right? So in rock, other solid particles are not free because rocks come in the solid, so they are not free to move around. But in liquid and gases, they are free to move. As they move, they collide each other and bounce back in all directions, right? Because they are free to move in each other, so particles are colliding to each other and they bounce back in all direction like x-axis, y-axis, or z-axis, right? So the path of one particle in liquid or gas could look like this. So I will explain this point. So the path of one particle in liquid or gas look like this. Suppose to here. So particles are going this like this, right? So this is the path of the particles which is moving around, right? So this is coming from here to here. So particles can move in any direction. So the particles move in any random way, changing direction every time. So their direction is changes every time it hits another particles, right? And we will call them as random motion. So when it particles are moving in any direction, that is called random motion. Random motion, right? Now look at the some evidence of particles, right? So we'll look the some proof. So there is evidence all around you that things are made up of particles that they move around in liquid and gases. So look at these examples, right? So this is the cooking, right, area. So you see here particles are there. So you often see dust and a smoke dancing in the air in the bright sunlight. Dust and the smoke are cluster of particles. They dance around because they are being, right. So in cooking, smells can spread out in the street. This is because the smells are caused by the gases particle mixing with and moving through the air. They dissolve in moisture in the lining of the noise, right? So smells spread all around. We often see dust and smoke dancing in the air in bright sunlight. Dust and smoke are cluster of particles. They dance around and they are being bombarded by tiny particles in the air. So this is the evidence for the particles which can be seen all around us, right? Now look at the many more evidence in the lab, right? So place a crystal of potassium magnet in a beaker of water. The color is spread throughout the water. Why? First particles leave the crystal, it dissolve, then mix among the water particles, right? So when we placing potassium magnet in the water, its particle is spread out. So you can see here in this diagram, white particles is called water. So this white one is water particles, and this blue one, it is called particles from the crystal mixed among the water molecules. And you can see the crystal of potassium magnet 7. Now look at the second evidence on right hand side. Place an open gas jar of air up down on an open gas jar containing few drop of red brown, right? The color is spread upward because particles of the brown vapor mix among the particles of the air. So you can see that here we are mixing an open jar. So this is your air, water, air. White color is air particles, right? And brown one is bromine particles and air particles now fully mixed. So this is the mixture of air and bromine water, right? So your brownish color is brown particles. So this is the also mixture of gases. Now look at the next topic. Our next topic is diffusion. In all those examples, particles mix by colliding with each other, right? And bouncing off in all directions. So particles are mixing each other in all the direction. That is called diffusion. So when gases combine each other, that is called diffusion. The overall result is the flow of particles from where they are more concentrated to where they are less concentrated until they are evenly spread out, right? So in this way diffusion occurs in the gases. Now look at the next particles. So what are these particles? So what is the particles? What about the particles? The very small particles that we can't break down further by chemical means, that is called atoms. Okay? So a smallest particle is called atoms. So in some substances, particles are just single atoms. For example, argon. A gas found in air is made up of single argon atom. So argon is a single atom which exists in gas form. In many substances, the particle consists of two or more atoms joined together. These particles are called molecules, like water. So a water contains two atoms of hydrogen and one atoms of oxygen. So this is the water molecules. So when atoms combine, it forms the molecule. So water, bromine, and gases nitrogen and oxygen in air are made up of molecules, right? So when two atoms combine each other, then it is called molecules. Next one is in other substance, like particle consist of atom, group of atom that carry a charge. These particles are called ion. The potassium magnet 7th is made up of ion. So atoms of group of atom that carry a charge, right? When atoms carry charge, that is called ion. That is called ions, right? Example is potassium magnet. Now look at the next point. Seeing particles, we are now able to see the particles in some solid using very powerful microscope. For example, the image on the right show palladium atoms. So this part is called palladium atoms, right part. Sitting in the carbon atoms in this image, atoms appears over 70 million times larger than they are really. So right one is called palladium atoms. So this image are very using a Stilling electron microscope. The white blobs are palladium atoms. The blue one are carbon, right? So blue one is called carbon. Rest one is palladium. Look at the next topic. That is solid, liquid, and gases. So now next topic is what's the difference between them. So it is easy to tell the difference between solid, liquid, and gas. So you can see this diagram belongs to solid state. A solid has a fixed state. So you can see that This object having fixed shape and fixed volume, and it doesn't flow. The think of all the particle things around you, their shape and volume do not change, right? So the object which is belonging to our surrounding is also called solid state because their shape is not changing, right? So now look at the liquid flow easily. It takes a fixed volume, but its shape changes, right? So its volume is fixed, but it changes the shape, right? It takes the shape of the container you pour it into. So in which you liquid pour now, you take the shape of that container only. So now look at the gas. A gas doesn't have a fixed volume or shape. It is spread out to fill its container. It is much lighter than the same volume of solid or liquid, right? So this is the main difference between solid, liquid and gas. Now look at the next topic, water, solid, liquid or and gas. Water can be a solid, that is called ice, liquid, that is called water, and a gas, that is called water vapor or steam. Its state can be changed by heating or cooling. So I have fixed here a thermometer showing 0 degrees Celsius temperature, ice cube melting, right? So this is the solid particles which is melting, that is called ice. Ice slowly changes to water when it is put in a warm place. This change is called melting. The thermometer shows 0 degrees Celsius until all the ice has melted. So 0 degrees Celsius is called melting point, right? Now look at the second diagram. When the water is heated, its temperature rises and some of it changes to water vapor. This change is called evaporation. The hotter the water gets, the more quickly it evaporates, right? So this is the second case or liquid second state of water. Now look at the next third one. So I have fixed a thermometer here showing 100 degrees Celsius temperature, water vapor invisible and the steam visible, and here it is boiling water. Soon bubbles appear in the water. Boiling, it is boiling. The water vapor show up as steam. The thermometer stay at 100 degrees Celsius while the water boils off. 100 degrees Celsius is called boiling point of water, right? So these are the three cases of water. Look at the next point. So when a steam is cooled, opposite changes take place, right? So this is a steam. We cools below 100 degrees Celsius, condense to form water. Now cools below 0 degrees Celsius, so it freezes and solidifies to form ice. So we can see that condensing is the opposite of evaporating, right? And freezing is the opposite of melting. And freezing point of water is the same as melting point of water, that is 0 degrees Celsius. So this is the reverse process for water. So that's all for today. We will meet in next class or next part of this video lecture. Thanks for watching. Please like and subscribe my channel also.